Welcome to my presentation for Physics 2212, Lab 1 on charged tapes. In this presentation, I will introduce the experiment and explain some fundamental physics principles, discuss my observed results, including some observations and collected data, describe a computational model I created in GlowScript to accompany the experiment, and conclude by answering some additional questions. The purpose of this experiment was to evaluate the amount of excess charge that an everyday object can have in a typical environment. In this experiment, I used clear tape to do this. Another purpose was to utilize Newton's second and third laws, along with Coulomb's law, to determine physical properties of a charge. This resulted in discovering that the U-tapes repelled each other because their charges had the same sign, either both being positive or both being negative. I later found out that the tape was positively charged because they were attracted to the negatively charged pen. I was able to calculate the charge of the tape is approximately 1.34 times 10 to the negative 8th coulombs, and that the number of excess electrons was 5.84 times 10 to the 11th electrons. Some key fundamental physics principles to understand going into this experiment primarily include Coulomb's law, which is denoted by the equation F is equal to K, a constant, multiplied by Q1 and Q2, which is the two charges, divided by R squared, which is the distance between the two particles squared. This picture here on the right also shows us that like charges will repel and opposite charges will attract. We also can calculate the electric field, the force on a charged object, and the force of gravity on an object using the equations shown on the screen. So this experiment was broken into three main sections. First, we need to charge the tape, then test it, and then determine the excess charge. So I started with my base tape and put a U-tape almost completely on top of the base tape, and then ripped it off in order to charge the tape, and did this twice to get two U-tapes. Then I did some experiments to test this charge, including holding my hand near one of the U-tapes, holding the two U-tapes together, holding a neutral object near the U-tape, and then holding a negatively charged object near the U-tape and observing the interactions between them. Finally, I was able to determine the excess charge by attaching one of the U-tapes to an object at each end to hold it still, as shown in the picture on the bottom right, then holding a second U-tape parallel to the first U-tape and bringing it closer to the first U-tape until it began to float, and then recording the distance between the two. So in this experiment, I was able to observe that the two U-tape strips repelled each other, revealing they were like charges. And then I was able to discover that the U-tape strips were attracted to the negatively charged pen, which indicated they were both positively charged. Now, a few assumptions about this experiment. First, that the tape acts as a point charge. Second, that the tape's charge was located at the center of the strip. Third, that each U-strip piece of tape had the same amount of charge, with the charge evenly distributed throughout the entire strip. And fourth, the air resistance was negligible and therefore could be neglected. So some collected data from the experiment include the length of the U-tape, which was 0.2 meters, the width of the U-tape, which is 0.02 meters, and the distance when the U-tape began to float, which is 0.03 meters. Using this information, I could calculate the surface area and the number of atoms, and using the mass of the tape, I was able to calculate the magnitude of the gravitational force. Using Coulomb's law, I was able to calculate the charge of the tape, which was 1.34 times 10 to the negative 8th coulombs, the number of excess electrons, and the ratio of excess electrons to atoms, all of which are shown on the screen. Afterwards, I was able to create a computational model that reflected my real-life conditions. So I used those same data points that I had collected and input them into the code that I created in order to calculate the charge on the tape, which here was 1.4 times 10 to the negative 8th, which is really close to what I had calculated earlier. So in the model, the blue dot represents the U-tape on the top, and the red one represents the U-tape on the bottom, and then the yellow is the electric field caused by this experiment. So a few additional questions as well in conclusion. So if the electrons had actually had a positive charge and the protons had a negative charge, would these properties affect the experiment, and what would and would not have changed? So even if the charge would have reversed, the tape still would have repelled. Because both tape would have had the same charge, it wouldn't have mattered if it was both positive and both negative, they still would have repelled. This means that we'd be able to see the tape floating because a interaction between the two would have been visible. Secondly, why is it important to handle the charged tape as low as possible, and what happens when the charged tapes come in contact with your hands or other objects. So electrons can be transferred between surfaces, including the tape and other objects, and including my hands, which could be affecting the end results. So it was important to make sure that you handled them as little as possible. But this experiment was really insightful and enlightening on the charges of objects, and it was really cool to see. Thank you for watching.